here's the deal. We will be talking about designing networks, mostly predictive designs or predictive modeling, whatever you call it. I guess I'm assuming you guys were talking a little bit about combining the term site survey with network planning, right, Jim? Or
yeah, and just kind of banishing the word site survey from your vocabulary, at least when you're talking to people outside the engineering area about it.
Absolutely. So what should we talk about? What should be the correct term?
Well, you should talk about the work you're actually going to do. So if it's a predictive model where you're just sitting in front of a laptop with a design tool like Hamina, let's talk about that. If it's a validation, if it's on-site RF validation, you're going there and taking measurements, let's talk about that. If it's troubleshooting or remediation or something else, talk about those things.
Sounds fair. Sounds fair. We'll try to keep that in mind today and not butcher it too badly. All right. Yeah, I mean, did we introduce ourselves? I don't know if there's need to. Well, Joe, I can start. I'm Jussi, janitor at a company called Hamina. We'll talk a little bit about that later on, and we'll get a demo in a couple of minutes, so stay tuned. Joel?
Yeah, I'm Joel. I'm the assistant to the regional janitor at Hamina. And yeah, I don't know. Jim, do you want to say hey really quick?
Hey, I'm Jim. You guys see me every week. Good to be here. Eric is here. He's lurking in the shadows, deep in the catacombs. He'll emerge after this is done.
All right. And this is the 5-second consultant spiel that I'll show you. So with Wi-Fi and with all kinds of IoT technologies in the enterprise, and now private 4G or private 5G. Usually it's called private 5G, although it's really private 4G at the moment, and then fixed networks. So designing all of this stuff. That's what we're gonna talk about today, since the enterprises typically are full of all of this. And I mean, at Hamina, you may not have heard of us. We've only existed for like 1.5 years. We do network design tools for different technologies like Wi-Fi, 4G, 5G, BLE, stuff like that. And we also do a little bit of switching, cabling, PoE, all of that stuff. But here's the beef though. Win-free Hamina. Just literally made this up 2 minutes ago, and it doesn't actually come in a 3-dimensional box as you see there. But either way, if you want to win a free copy of our first and flagship product these days, which is the Hamina Wireless Planner, just tweet something about this webinar at some point or post something to LinkedIn at some point and just mention our company. So on Twitter, it's at Hamina Wireless. And on LinkedIn, it's Hamina Wireless. I think when you're posting on LinkedIn, if you start with @ and then type Hamina, you should be able to find it. And yeah, this is a relentless advertisement because we live on likes and tweets and retweets and all of that. So if you want to win a free copy, just Jim and Joel, please remind me that we need to do the raffle towards the end of the webinar. All right? Fair? Excellent. So, I mean, we're kind of on a mission to disrupt a little bit the whole network design, network planning, predictive modeling, and also in the later stages, RF validation and all of that. So our network planner starts at just $390 for 6 months, no upfront fees, no penalty if you skip a few months after that or whatever. So we try to make it really reasonably priced. There's nothing to install. There's absolutely no barrier. There's no excuses to get started. If you have any kind of Wi-Fi to start designing, you just go on our site. You'll be using the tool in 1 or 2 minutes, and even using the tool is, I don't know what I just made up, easier than unwrapping a Snickers bar. I don't know if that's even a thing, but it is now. So yeah, and that's our website. So that's all the slides I think you'll see today from any of us. Is that fair? So I guess what we could do is jump into the demo. All right. You guys ready to go? Joel, should we talk a little bit about like Q&A, how are we going to handle that before we jump into the demo?
Yes. So there's lots of excellent banter in the chat, and I think we should keep that going. I appreciate that a lot. But there's also the Q&A tool. So if you want to make like absolutely sure that we get to your question, then go use the Q&A tool and put that in there. And I'll either answer it via text on the fly, or maybe I'll flag UC down at some point. And some of them we might even save until the end. So we'll just see how things go there. But please feel free to use the Q&A tool and the chat.
Excellent. Excellent. So yeah, anything you have, just drop those in. And yeah, Joel, just feel free to interrupt me, Jim, or anybody, just feel free to interrupt at any point, and we can, you know, do a deep dive or answer some questions or what have you. All right. So today we're going to focus on demoing the product and kind of that way, looking at designing Wi-Fi, 4G, 5G, BLE, look at a little bit of cabling side of things, as well as reporting. I think that's what we promised in the webinar advertisement. So least we can do. How much time do we have? We have plenty. So should we start from scratch, actually? How about that? So we're just going to make a new project. Let's start with a university, and then we'll look at, let's say, a more challenging environment later, like a I don't know, warehouse, something like that. So regarding our tool, so it's completely web cloud based, all of those hype words, and you know, 3-dimensional, GPU accelerated, you know, you name it, we got it. And this is what it looks like. So on the left hand side, we have the selector of projects, a couple of buttons here, and then the main tools are here, like, you know, editing, scaling the drawing the walls, placing access points, all the key tools are here. And on the top right hand side, up here, let me just move the controls of the webinar down. Up here, we have generating reports, sharing the project, and then some account details. All right. So I said, let's start with the university. So I'm just going to drop in a PDF floor plan, but anything is good, like PNG, JPEG, you know, PDF, CAD files, whatever you throw at it. Even WebP, if you take images directly from your phone, like photos and stuff like that, that's all good. That can totally be used. So while we are importing the image, it's not just about like, you know, uploading the image. We're actually you know, reading the image as well, and kind of processing it a little bit at the same time. Here we have the image, and of course this, like, the smoothness of the tool and the way it's like 50 frames per second all the time doesn't, of course, convey through Zoom, but take my word for it, it's all the time very smooth. And now, first step in a drawing like this, Jim, what would you do if you saw a floor plan like this?
Start drawing walls and doors and things like that.
Exactly. But should we do something about the background colors first? Because this looks pretty ugly, right?
Yeah, go black and white or grayscale. Yeah.
Let's at least remove some of the color.
Just owned all of us in the chat. JJ just owned all of us in the chat by saying scale.
Yeah, exactly.
So, sorry, I interrupted your demo. Do your thing.
Step number 1, scale, for sure. But step number 0, I would say, is clean up the drawing a little bit. And we have this color removal tool, so you don't need to go to like GIMP or Photoshop or PowerPoint to edit images. Who edits images in PowerPoint anyway? This guy, but nobody else. So anyway, I just took out while I was importing the image, or while the system was importing the image, it scanned it for like colors you might want to remove, and I clicked on some of those, and now it looks a lot cleaner. You know, it actually makes sense now to place notes and heat maps and things like that on the map. But yeah, like Jim said, I guess we should probably put in some kind of a scale. And so if we did the do not try this at home scale, that would be like 1 meter for the doorway, or you can change it to feet by clicking here. Don't try this at home. I just did it because I'm too lazy to find anything else. But essentially, we would just find a place where there's an actual scale and put it in. All right, so that's done. Scale is done, and no more blinking warning lights in the tool. Next step would be either drawing the walls, like Mr. Vajda said, or we could actually cut some corners. And since this is a PDF file, and PDF files most of the time they're vectorized, they have all this kind of, when you look under the hood on a PDF file, it has all this crappy stuff. But from all of that, we can actually start seeing, actually these look like windows a little bit. So I'm going to say that's window layer in this PDF. And maybe those are some kind of drywall. And then maybe those look like doors. So now anything that has color on it will actually be automatically assigned into walls. And this is starting to look pretty good. We can always bring back more walls later, of course, and it's completely integrated into the UI. But let's first bring those walls here and see what happens. So this just means we do not need to draw the walls. And here you can see the end result. That actually came pretty good. There's the walls with blue color. There's the drywall with. And this works on, vectorized PDFs as well as CAD files. So, and since we're still missing a little bit, like here, we didn't get the staircase. So let's actually draw that manually. I'm just going to say that's obviously a brick wall. Since it's probably fireproof, I could even use concrete and probably not go too wrong with that. So I'm just going to say, that's concrete right there. All right. So we can manually, of course, fine tune this as much as we like. All right. So there we have a pretty decent model for moving on. Okay, then we're ready to start designing. Let's start with Wi-Fi, the easy, obvious stuff. So since we are not in for anything but latest and greatest, I'm just going to deploy the Aruba 655s. And this is kind of the minimum set that we need to use. Since this is a carpeted indoor space, I'm just going to say, yeah, sure, ceiling is fine. And then, the average or this height is probably all right. And, you can choose from different mounting types. Kudos to Drew Lens. There's also a Wi-Fi stand here and all kinds of wall mount, floor mount, L mount, whatever you have. And I guess we're ready to start designing. And one of the key things for design, of course, is requirements. And that should be the kind of the first and foremost thing. And for us, design, like requirements is not only about numbers, but it's what you call them. So this is important in customer deliverables and reports, because this is what the customer will also see, is the thresholds you set. So anything above -65 is high and green. Anything between -65 and -75 is decent and yellow, and so on and so forth. And that is then reflected on the map as well. And as we start painting the map green, if you will, let's look at 5 gigahertz instead of 2.4. Well, let's actually look at 6 gigahertz since we have 6 gig capable APs. All right. And yeah, that's starting to look good. I'm going to hide the AP numbers. I'm going to hide the walls since we are done with the walls, and we can start designing. Of course, this doesn't show up to you as real time as it is on my local computer, but you can see as I move the AP, the coverage patterns immediately update. And as I place APs, you can see the channel planner is run every time I do changes to the network. So we can see 1, 6, 11, 6. And if I place, if there's an auditorium like in here, and I place several APs, then it might disable some of the 2.4 gigahertz radios and stuff like that. And let's actually look at 5 gigahertz since some of the external APs may not support 6 gig. So we could we'll put in an Aruba AP that has an external antenna on it. Well, let's use Axeltex for that. And then we'll use a highly directional antenna. And in this auditorium, we can only place APs as high as 15 feet because they have to be mounted in the ceiling, or even, sorry, let's say 25 meters. So it's a very high ceiling auditorium. Well, that's a really high ceiling, but let it be. And then since the signals don't quite touch the ground, since we're shooting to the side, let's just shoot down, and there we go, looking much better. And let's put one on each corner, or at least a couple there, and there we go, there we go, and there we go. And right now you can see that, yeah, actually the channelization algorithm actually disabled one of these radios and one here, because there's leakage from up here, and it sees like, hey, actually the 2.4 coverage doesn't get any better even if we utilize more radios. So we're only using 6 and 11 for this site and stuff like that. So we're starting to, you know, slowly but surely make a decent wireless design for the site. And of course, you know, there's different vendors here, everything from you know, MikroTik to Ubiquiti to Zyxel to Fortinet. You know, it's all here. And now would be a good time for some questions if there was any.
Yes, there are several. So there's a couple that I'm actually holding off until a little bit later. David's got an excellent question that's like a perfect setup for a feature that I think you're going to show.
Yeah.
Nick's got a question that's a perfect setup. We'll send those guys their $20 later.
All right.
David asks, will it read and auto scale with AutoCAD files?
Yeah, that's a great question. That's a great question. Joel, you want to take that or should I?
Yes. I can give a little bit of background on that one. So the short answer is yes. The long answer is trust but verify. I actually spoke to the engineers about this just a couple of days ago, and it turns out that reading a scale from a CAD file is not straightforward at all. It's actually all over the place depending on the CAD file. So at this point, I say, yeah, put it in there, but then just be ready to grab the scale tool and check really quick and make sure that it's right, because we see about an 80% success rate, but that 20% of the time could really get you. So just be sure to check on it and double check that it's right.
Great question. And yeah, so auto scale and the walls also, kind of like what I showed to you, it's identical, the UI, whether you get it from an AutoCAD or a vectorized PDF. All right, so should we look at switching a little bit? How about that? So yeah, I mean, I placed a couple of switches, one up top, one here at the bottom. So using the network equipment tool, it's not just about Wi-Fi, right? And especially with 6E access points, it's more and more about how much power are the APs draining. Let's say I have a 24-port 300-watt switch here. So far, so good. But if we keep adding more, especially if we keep adding more of those power-hungry 6E APs, we might be running out of power on the switch. We might be running out of ports. So definitely you want to consider those things as well. For example, if we had the same 300 watt switch here, we would see that's not gonna fly. And also if we have an extensive number of APs, or we have things on the network that are also draining, you know, switch ports from the network. Let me just disable the heat map real quickly, and maybe the channels as well. So if we have things like, you know, cameras and I don't know, environmental sensors and door locks and desk phones and whatever we may have that also connect to the switch, that also might eat power. You know, not only will we run out of power on the switch, but we risk running out of ports as well. And you can check the details here at the power and cabling details. So just make sure when you're, let's say when you start to roll out Wi-Fi 6E, and if you do a rip and replace for Wi-Fi 6E access points, first of all, you want to check the PoE power consumption of the Wi-Fi 6E APs. And secondly, you want to check out like, how does this AP work on low power mode? How many streams do I lose on the low power mode? You know, will it still work even if I don't have BT power, but I have AT power on my switch? Spoiler alert, I think all of them will work with AT power, but some of the you know, features will be reduced. You might be losing you know, some of the streams from use, spatial stream stuff like that. So might be losing some of the maximum data rates on some of the APs, things of that nature. All right, so here's a rundown of like the two switches we placed, whatever is connected to the switch, how much cable, you know, and we throw a little bit of slack on the cable. We also provide like warnings. Let's say if you if you know, have too long of a cable, not so fast. So considerations like that. And it's not just switches and cameras and things like that. It's also, you can put in like IDFs and you know, MDFs and things of that nature as well. That's kind of how you would work out the switching side of things. All right. So what else should we know? That now that we've done some of the fixed network, should we look at before we move into the BLE and 4G, 5G stuff? Should we look at client view real quickly? Joel, you want to talk through the client view, and I can present while you talk.
Yes, absolutely. Okay, so
what like alert? We've never done this before. I'm just throwing Joel under the bus. So.
Thanks. I appreciate that so much, UC. Thank you for throwing me under the bus. So with the client view, what our engineers have done is they've gone and they've looked at a bunch of different clients and specifically their band preferences, their roaming behaviors, their specifications, and they have plugged all of those behaviors into Hamina so we can basically simulate those devices. So like, for example, for the iPhone, they went and looked at Apple's specifications. For Android phones. They actually cracked open the Android open source project code and looked to see what the roaming behavior is. Then you can click and drag that client device around on the map, and Hamina will attempt to determine when the client is going to roam based on its band preferences and roaming preferences. Now, the way that I see it, we're never going to get this 100% right because roaming is such a deeply involved thing and every client handles it differently. And there's just a lot of factors that go into it, but I think we can get pretty close. And what we're overwhelmingly seeing our users use this for is they're using it as a training tool. So like, for example, if a customer says like, hey, in our hotel, just put the APs up and down the hallway, then our users, they do a hallway design and then they show them, here's what the roaming performance is going to look like with all the APs in the hallway. And that helps the customer or the manager or whoever it is understand that like, hey, that's why we don't want to do this. And so that's what we're seeing people use it for. So UC has thrown some APs in the hallway. So there you can see that our Android with 6E is associated with that AP and it just hangs onto that AP. Even if we go all the way down to the corner there, then when that client rounds the corner, it's just going to fall off a cliff and it's probably going to have a pretty tough time executing a roam to that AP that's around the corner there because there just wasn't a whole lot of time as that client was moving. It's probably not going to result in a good experience for the end user. So yeah, UC, is that everything? Did I get all the high points there?
Dude, you definitely beat me. Jim,
I've heard you give the spiel.
Should we throw Jim under the bus as well? Jim, what do you think, man?
This is really interesting. So the what it's drawing there is the client's coverage view from the AP, or is it it's the downlink, not the uplink?
This is the association area. So this is where it will stick to the AP, is the colored area. And once you move out of that area, it will roam.
That's interesting. I think
the
first time I saw this, I don't know if I noticed that the data rate was being modeled too. That's really useful. So you can kind of really see the issues. Like, for example, when you went around the corner, the data rate dropped significantly. Absolutely. And the MCS.
And the MCS.
Exactly. And when we switch from 6E Android to iPhone, we can see number of streams drops, 6 gig support drops and stuff like that. And now the data rates are much more conservative. But of course, that doesn't mean that the connection would be any worse. Who needs 900 megs anyway, typically. And we've seen things like iPhone, for example, does funny things when you're at a place of very low coverage. Then it will probably fall for a 2.4 gigahertz connection because that's where it gets the best, like better connection out of 2.4. And when you approach the AP again and you get better and better and better coverage, it will hold off to that 2.4 radio actually until it's time to roam again, because it's kind of determined like, okay, this is actually a decent radio. I associated here when I was at poor coverage, but it's working pretty well. So I'm going to hang on to this 2.4 radio, and depends on the client's band preferences. An Android phone, for example, will behave quite differently in that situation. Yeah. So just so initially, when we were talking to a boatload of Wi-Fi geeks, they were like, nobody has solved the roaming problem. You need to do some kind of roaming, stickiness evaluation and roaming estimation thing, so that I can optimize my roaming stuff. Then we give this to the public, and people are like, yeah, this is a great tool to show my customers how the network actually works. And we're like, no, that's not what it was for. But it's great that it's used. We don't care for what. And it turns out, people like to use this for reporting.
I think that's a good use for it. I think, one of the issues that you find is, and what we find with Mobileye a lot, is there's just clients that they don't do what their published specs say they're supposed to do, and they're sticky and they've got bugs and things like that. And they need help finding those specific clients and getting them fixed.
Exactly. And I'm sure there's like, what we live with is kind of the specs or the source code or like against NDA specs of how the roaming should work. But I'm sure like, the 7 signal system would catch those situations like, hey, it doesn't work at all like what Hamina predicted. And then you kind of start looking at, another driver bug or what have you. Anywho's. So that's that. Should we look at BLE a little bit? I think BLE typically would be used for location tracking services, things of that nature, right? And let's first look at the BLE heat map for just the APs. So what is this useful for? The primary coverage, probably not so much, but if we look at, and this is like just a red-green thing. So if we look at tertiary coverage, like let's say we want 3 APs at neg 70 everywhere. Well, that's a strict requirement. We're going to put 75. So this would be like, I would call this location okay, and then not so okay. So right now what we're looking at is, do I have 3 BLE signals audible in every location? And if we want this super accurate, like I want neg 70, we can see that not even close. So let's place some BLE beacons on the map, and of course these do not connect to your switch at all, because BLE beacons typically don't. They can if you want to, but by default they don't. And you can actually augment the BLE coverage to make your network location ready by utilizing BLE beacons as well. So this is just, the typical use case for enterprise wireless BLE. Or what do you think, Joel, Jim, any other typical use cases for BLE? I think Zigbee is more for like, ESL, electronic shelf labeling and stuff like that. But BLE typically, I would say location services, or what do you think?
I was tuned out answering a question, so I think it's all on Jim. I got thrown under the bus, so now I'm throwing Jim under the bus.
Wonderful. Yeah, definitely location services is the top use case for BLE beacons. Yeah.
All right. And to fill the map with even more stuff, how about we look at since we've been on the same project all the time, should we create Jim's warehouse? This is actually the warehouse where Jim actually ships his 7 signal gear out from to customers, especially the software. The software gets shipped from this warehouse. So
we send it on mini CDs. Yeah.
Oh yeah, you use CDs. I mean, we use 3.5-inch diskettes, but we're not we're not that advanced yet.
You guys are just getting started. That's okay.
Yeah, we'll get there. Okay. So now that we brought in a pretty rudimentary JPEG of a small warehouse where we want to do 4G, 5G network planning or private cellular network on a warehouse, what do we do? So we might want to draw these walls by hand. And I'm going to say the exterior walls are concrete, except let's say next to the trucks loading base, it's metal doors, but here it's concrete again. And I'm actually using the shortcut keys that you can see here to change the wall material so that I can pretty snappily just, go about and do the main walls. I'm going to hit D to do drywall here. There we go. And then I'm going to hit H for heavy drywall, draw a little bit of that. And you can see it intelligently snaps into different places on the map where it thinks, you may want to stop drawing and stuff like that. An example of snapping would be if I draw this wall of the janitorial closet, and then I continue drawing from here. It says, hey, you might want to snap here to align it perfectly with the wall on the janitorial closet and stuff like that. So So that's what we do, and I'm doing a terrible sloppy job here, but never mind. So that's how you manually would draw the walls if the drawing is not of great quality and good format and stuff like that. But it's not just the walls either. It's also attenuating objects like warehouse racks. So here we have a 7.60 meter, so I don't know, 30 feet warehouse shelf, which these happen to be. So I'm just going to say these guys are 30 feet, and there's our office cleaner. This is what you get from, if you can hear a vacuum cleaner, our office cleaner is here. It's what you get from an evening webinars. Anyway, so we did that shelf, and it's, of course, everything is completely customizable. I'm gonna make another shelf that's just 4 meters high instead of 8 meters. So this is half the height, and I'm gonna say that. So this is where you can customize everything when it comes to wall materials, attenuating objects. And the objects are kind of like wall materials. They have height, they have attenuation, but they're just thicker than walls. Typically, they attenuate a little differently and all of that. So here we go. We start to have the pallets in place. We have most of the wall materials. I'm still gonna draw a little bit of drywall in here. See how nicely it snaps, makes perfect drawings. Okay, so what do we got? We have walls, we have attenuating zones as the shelves. What else should we do? I like drawing the trucks as well, in case there's if in case we need coverage at the loading bays. I'm just gonna do, we have a truck material pre-made here as well. So these are yellow trucks. They're not brown like UPS. I don't know which would be yellow. Maybe postal offices, something like that. All right, here we go. Fair. So we have now fully modeled this small warehouse, and we are ready to start doing the 4G, 5G planning. And let's just, I don't know, we'll use Airspan 1030 for 4G, or is this 5G access points, and we'll start rolling. But before that, what do? We set the scale again. And again, he's using the door. Do not use the door, you see. You use the door, you fool. Sorry about that.
I think Heather really might kick you out this time.
Oh, man.
My hand's on the button.
This is the most brutal webinar I've been in, like, at least 2 days. All right, so here we have the AP. And as you can see, since it's a 5G AP, it actually provides quite good coverage. Even if it's placed low, it goes through many of the shelves quite well. But in this case, we probably want to put it to the ceiling of the warehouse, and then we want to give it some down tilt. Here we go, and you can actually see the ripples here quite nicely, as you can tell. So that all the antennas are really carefully 3D modeled, so you can see the impact it makes and kind of the ripples of the omni pattern and all of that, which is kind of cool to see. And then behind these highly attenuating shelves, we would probably put an AP for each of the, what is this shelf, between each shelf. I don't know how you say that in English. So, and as you can see, it's also optimizing the CBRS channels for now, not just Wi-Fi channels. And since, with CBRS, I guess typically we would have less channels available. We could just untick some of these, and whatever we get from SAS or spectrum allocation system or whatever is, actually. So now it rerun the channel algorithm using just those channels that we have. So there we go. That's kind of like, all I'm trying to say is designing private cellular doesn't have to be way more complicated than anything else. And I mean, here you have the same settings as for all of the Wi-Fi radios, like, transmit power and all of that. And we want to probably have that in dBm. So there we go. But yeah, this is, that's the thing.
Hey, UC.
Yes, sir.
There's a question from Nick ages ago. Feels like it was almost years ago at this point in the webinar. But Nick said, do you have an example of a warehouse where you can compare the number of Wi-Fi APs needed with the number of CBRS access points that are needed to provide similar coverage?
That's a great question. So if we really optimize this and can live with decent coverage here and there, let's say this would be maybe the number of CBR SAPs that could be used in this small warehouse. The problem here is that very thick shelves, so they attenuate a lot, no matter the technology, no matter the frequency. But we would use probably 4 here. Let's look at Wi-Fi next. That's a great question. We should almost declare like an extra winner here for that question. That's a very good one. This time let's say I'm gonna use Juniper AP43Es, and we're gonna design for 5 gigahertz. All right, so I'm just gonna say primary coverage for 5 gigahertz, so that it's a fair comparison, and using the default settings in the tool, so that it's, I don't know if it's fair, but we'll just live with that. I'm going to use Axeltex antennas again, put these on something like 15 meters, point them down a little bit to get better coverage. And here we go. You can actually see that here we do need more APs. We can't quite cover here, so we need 1 there. We still need 1 in the office. We'll put that later because that's probably going to be a normal, integrated antenna AP. But we need 1 here. We need definitely 1 for each shelf, between each shelf for Wi-Fi. So I'm going to put those in, and let's take out the channels so that we can see this better. Here we go. Then we'll put in a Wi-Fi AP again here. And it's starting to look decent for Wi-Fi coverage if we look at the overall Wi-Fi coverage. But I would definitely put 1 more here in the room. And let's actually color the APs a bit differently. So we'll put Wi-Fi APs with a different color. We should actually have a different default color even for Wi-Fi APs. So I'm going to say these APs are orange. Can we see them very well? Maybe not. I'm going to say red. Wi-Fi AP is red, 5G AP is blue. All right, and then 1 more. Let's say we'll use standard 43s for the office here. So what did we get? We got 1, 2. Well, actually, why are we even calculating this? Shouldn't we look at the bill of materials? Here we go. So we have 7 Wi-Fi access points, 6 with integrated antennas, and 1 with integrated antenna. And then for 4G, 5G, we have 4. So in this specific warehouse, don't take this as any kind of, you typically need a lot less, I would say CBR SAPs, but that's kind of what we're looking at here. And it's a nice way to look at our bill of materials tool, which automatically generates like bill of materials, and then you can customize everything to your liking. So all the fields are customizable. You can add prices and brackets and what have you here. But that's kind of how we build the bill of materials. And if you also use things like, I don't know, switches and stuff like that, that's also there in the bill of materials. And those, I don't know, desk phones. Who uses desk phones? Well, a lot of companies apparently. Nothing wrong with that. So all of that is in the bill of materials. All right. So not just the wireless stuff, but the wired stuff and the cabling and the desk phones and what have you. I hope that answers the excellent question that we got there. And then if we don't want to care about outdoor coverage, of course, if we did, we could just place an AP outdoors and then it would calculate that. But if we don't want even to show the outdoor coverage, we can just create an out of scope zone here. So we want to limit kind of the area of interest inside the map here. So everything else is grayed out and only the map remains. And then if we want to exclude the janitorial closet, we just draw another out of scope zone here.
And men's room is in scope.
Oh, that's definitely in scope. So here we go. One more thing at least we promised to show was how to generate customer reporting out of this. So let's create a new report out of the Jim's warehouse.
And while you're typing that in, you see David said, does Hamina have a free viewer? For example, if I create a design, can my cabling contractor view my design for free? So David, here's the answer to your question.
Yep, this is the free viewer. So you can send unlimited number of reports to anybody. This is kind of the preview screen that you use to customize, everything that you see on the report. Jim's bill of materials. This is for the warehouse hosting all of Jim's CDs, mostly Nirvana and Radiohead. There we go. So all of these screens are configurable. And what's beautiful about this is if you want to see coverage maps, it's not like postage stamp sized PDF, images on a PDF drawing. It's actual zoomable, drillable in reports with clickable APs. You can see all the AP details here. If you only want to create a report with AP placement for the guys who are placing the APs, they can totally see the same stuff without the coverage map, stuff like that. It hosts everything 4G, 5G, BLE, switching and cabling. If you want to see just, where are the switches or what is my switching inventory and how is it connected via cable and stuff like that. All of that can be done here. And then you just click the share button and share the report. I'm going to say Walrus is the password. I'm going to create the link. I'm going to copy this guy. And then dare I send it to the chat here? Is there?
Oh, yeah.
Yeah, not that anything has ever broken down before.
What could go wrong?
That might not have been clickable. That's definitely clickable, and password is Walrus, of course.
You said the password is
Password is Walrus, yeah. You guys got that?
Yep, Jim's warehouse of CDs.
Yep, I got it.
Anders says that we should really do this on Nakatomi Plaza. So next demo we do, this will be done on the Nakatomi Plaza floor plan. All right. So that's much of how Hamina works. There's also a lot of yippee-ki-yay. So yippee-ki-yay, you can share this with the Hans Grubers and Carls and John McClains of the world by just clicking the share. So there's difference in reporting and sharing. Reporting is typically for somebody who's just reading the report, and in the report you can kind of control, you can hide what you want to, what you don't want to show to the customer. If you don't want to show them the interference graphs or tertiary coverage or data rates, you can hide that stuff. But when you click share, you actually share the entire project. I could share this with Jim, so Jim could continue on the project and then share it forward to Joel, who could then work on the project further and stuff like that. So there's different ways. Sharing is for your colleague. Creating the report is typically for an end customer or somebody who only can get read-only access. When you share, you give them write access and you give them full rights and you give them the permission to share the document further and create reports and stuff like that. There's a lot of stuff that we covered, but we only had an hour. We still have 10 minutes for Q&A, unless we want to talk about how this actually gets directly exported into different cloud-based systems. I'm just going to say all you need to do is click a button from Hamina and it will automatically create the site. Let's see, in Meraki, Mist, Extreme, Arista. Click of a button in Hamina, it automatically creates the site, the new site in Meraki, pushes the access points from inventory to the site, pushes the maps, pushes the AP locations. You don't need to go to the Meraki dashboard to start up a new site in the Meraki system. All you need to do is the RF design, click a button in Hamina, and it exports it automatically. Meraki, Arista, Extreme, Juniper, Mist, and many more vendors coming soon.
Awesome. I feel like it's probably a good time to bring Eric out of hiding too.
Yeah.
Something to talk about. There he is. Oh wow. Ooh, pretty colors.
Beautiful colors. Boy, how do we change that? Let's go to our settings, shall we?
Yeah,
and
maybe
go
just
to our
switch camera off and on. There we go.
That was just a really cool transition.
Yeah, I was just feeling a bit psychedelic there for a moment. I apologize, everyone. But hopefully
Those
you
heat
can
maps
see me
get
and hear
me too.
Yeah. You okay? Are you dizzy?
Only
We're
a little.
okay.
We'll recover
Okay,
fully.
great. All right, guys. Well, hey, thank you for that. That was awesome. Appreciate it, UC and Joel. I mean, now it's time for a little bit of 7 minutes with 7 Signal. This is where we take a little piece of 7 Signal, unpack it, show you how it can have really awesome value. So let's do that together. I'm going to share my screen here, and let's do that. And oh my gosh, who is that and what is that? Wow, Hans Gruber. Alan Rickman, may he rest in peace. Sorry, guys, I just had to, I heard the reference and I just wanted to share a little bit here, but let's get into Mobileye, shall we? So today we are talking a little bit about roaming, were we not? And so I wanted to take an opportunity during our little time together to unpack how we do a bit of roaming analysis inside 7 Signal from the device's point of view. So we're looking at somebody's computer here who has Mobileye running. And as you guys know, when Mobileye is on your laptop computer and when you take that laptop upstairs, downstairs, across the hall into the conference room, we're actually tracking all of the roaming that's taking place. And in that manner, we can perform an analysis in order to determine if the device is doing a good job or not. As you can see here, we've identified a device that's doing a very poor job. Let's take a closer look, shall we? So every few minutes, as you can see on my screen here, guys, we're tracking the signal strength of this person's device. And boy, I'll tell you, this is bad news. Minus 74, minus 78, minus 76. But wait a second. When we look around this person's computer, and we do this by querying the operating system, hey, can you give me all of the data that indicates all of the other SSIDs and their signal strength all around you, please? And when we do that, we identify the best neighbor. And as you can see in this case, the best neighboring access point is minus 44. Oh my gosh, guys, you know, Mark is sitting right next to this access point. And this is really powerful because when people call you up and they say, hey, the Wi-Fi network design is terrible. The Wi-Fi is awful. Well, wait a minute here. Now with this evidence right in front of me, it's like, hey, can you look up? You see that little blue dot in the ceiling there? Okay, see, the network has been designed properly. It's right over your head. Here's the problem. Your device decided not to roam. Okay, so let's take a closer look at your device and its poor behavior before we point the finger at the network, right? I'm sure UC and Joel can appreciate that. Check this out, guys. Not only are we tracking the best neighbor, but we're also showing you the roaming history so we can see how this device has roamed from one BSSID to the next BSSID, and it's all time-stamped. So we can actually see the behavior of this device and how it has performed so poorly over the course of hours, days, weeks. We're storing 90 days of data in the cloud for you, my goodness. And we don't have the names of the access points here. We just have the BSSIDs, but imagine the names of the access points here, where you can then actually know where is this person in space? Where are they connected? What are they connected to? And if that wasn't good enough, down here, we're even drawing a picture for you, where every few minutes we're taking a snapshot of what's in the air. And this is obviously somebody at home with a mesh network. And you can see the co-channel interference. This is how it always is, guys, right? The ISP just passes out routers to everybody in the building, and they're all on either channel 36, 80 megahertz wide, or channel 149, 80 megahertz wide. And so we all have to deal with this. Picture, we can now see what's going on. If we were smart and if we had the ability to go into our router and change the channel, then maybe we can overcome this situation. But I love this example because this is just perfect in how it shows that, oh my goodness, mesh networks are not necessarily all they're cracked up to be. Look at this. Look at this, guys. The shoebox goose network at minus 75, at minus 75, at minus 83. You got to spread these things apart, everybody. Get these things apart. You're not roaming. You bought this awesome mesh network. You put these nodes all around your house and you don't roam to any of them. You're always at poor signal strength. What's the point of that? With a system like this, you can now evaluate how well or how poorly these devices are performing with your awesome design that you just created. And there you have it, ladies and gentlemen. Okay, so I just want to remind everybody out there, this is our time for today, but you and me, we can't see, we can't hear Wi-Fi, but 7 Signal can. Thanks for joining us, everybody. Heather, back to you.
Awesome. Thanks as always, Eric. It sounds like we had a raffle winner out there. If y'all want to announce that, I'm sure everyone saw it in the chat. got to give him a shout.
Absolutely. Joe Clark, congratulations. You won free Hamina. Please, we actually direct tweeted you already. So Joel hopefully has some kind of a mechanism to create licenses of the tool.
I do. I have the keys. I can do it. So Joe, just make sure if I forget, then just make sure you get your free license. You might need to remind me, but we'll get it done.
Exactly. And if you want to know more, go to our website. If you want to start using the tool, it takes 1 minute to sign up and learn it, and a second minute to purchase, and it's starting 390 USD. So it's less than a Snickers bar with all this inflation.
What kind of Snickers bars are you buying?
The good kind. Can't you tell?
Gold leaf. Yeah, only the best. Well, I feel like that is an awesome way to end the session. Thank you so much, UC, Joel, Eric, Jim, all of you for being here. You know where we'll be, same time, same place next week. So we will see you there. Bye-bye, everybody.
Thank you so much, Heather from Starbucks.
See you next time, guys.
Thank you so
Bye.
much, everybody. Thanks for having us on.
All right.